What's going on, guys? Welcome to another Java video. In this video we're going to be talking about chapter 3 using methods, classes, and objects. For the majority of this video we'll probably be talking about conceptual stuff in chapter 3 and just do some coding examples along the way. And at the end of the video we'll just do like a coding example where we dissect some code and just kind of explain the concepts in chapter 3 through the use of code. So let's get right into it. So the first thing we're going to talk about is what a method is exactly. So in previous chapters, we kind of defined what a method is, and we kind of played around with the main method. And so a really general definition of what a method is, if you forgot, is that a method is a series of statements that performs tasks. It's literally just that simple. We just perform tasks through the use of methods, so every method performs a specific function. So if you have code in, let's say, a main method where you want to print out something, then that's just a task that the main method is carrying out. So in really broad terms, a method is just a series of statements that performs tasks. Now, in the past, all we've worked with is just the main method, but what's interesting about coding is that you can create your own methods. And so anytime you create a method, it's imperative to note that a method is part of a program and it's declared in a class. So anytime you create a new method, or like the main method, it all has to exist within a certain class. And you can execute methods by calling them from other methods. So let's say you have a method that exists outside of the main method, you can call the method inside the main method, and that's how you get the method to actually execute. And the way you execute the method is by, having the name of the method and then just the two parentheses at the very end. So let's say I put that line of code in the main method, it would call the method called calculate worker pay, and it would calculate the pay for all my workers or something. So just know that you can create different methods and that you can call those methods in order to execute their functions. And you can call the methods by calling them inside different methods. We'll look at some examples if that's kind of confusing. So there's certain guidelines and parameters you have to follow when creating methods. So as we talked about, we talked about what a method header is and what a method body is. So of course, when you create your own method, it has to have a method header and it has to have a method body. So like public static void main string args is the method header for the main method. So if you're creating your own method, you just have whatever you name your method, and that would be your method header. And then within your method header, you have a method body. So maybe you want to just display your name and address, so that would be considered your method body. And so those are two things that you must include in all methods that you create. Now, when you're actually declaring methods, there's specific words that you have to include in the method. So the first thing you're going to do when you're writing your method header is you have to specify the access level of the method. So you have to include what's called an access specifier. And that's, when you see the word public or you see the word private, that's an access specifier. So that's the very first word that's going to be included in your method is the access specifier, whether the method's going to be publicly available or private. We'll talk more about what that means exactly later on in this chapter. The second word in the method is going to be the return type of the method. So sometimes methods can return certain things, like if you want it to return to you a data type, like maybe you're asking it for some kind of information and the method's functionality will return a double or an integer to you, you would just write that there. A lot of methods that we're going to be working with have a return type of void. So if you just want to print out your name or your address, then obviously, the method isn't returning anything to you. It's not passing any information back to the method. So in that case, you would just have the word void there to indicate that, there's no information coming back to the method. And so after the words public and void, so after the access specifier and the return type, you have the method name. So the method name can be, whatever you want it to be. You can call it, display name as they call it up here, or you can call it display name and address, or whatever you want to call the method is the name that you give it. Now just keep in mind when you're writing your method names, it's really similar to writing variable names in that you have to camel case it. So notice how display name, the D is lowercase, and then the second word, name, is capital. So just keep that in mind. And then at the very end, you have to have a set of parentheses when you're writing your methods. So the parentheses up here, every method will have a set of parentheses, and in some cases, you'll be writing stuff inside the parentheses. So we'll talk more about what that means exactly. So just to kind of go over an example of what it looks like to actually create a method, let's just do one right now. So right here I created a class, I just called it example, and then in the example class I have the main method here. So we already know what the main method is, so we're not going to worry about that for now, so let's just keep that blank. What we're worried about is creating new methods. So let's say I want to create a new method that just displays someone's name. So I'll go ahead and write public static void, and then from here, I have my access specifier, I have whether it's static or non-static, I have my return type, in this case it'd be void, and so now I just give it a name, so I'll call it display name, and then I have my parentheses, and then I open the method with my curly braces, and then in this method, I just wanted to display someone's name, so I would just write system.out.println, and I would just write, my name is whatever you want to write inside, right? And so we have this method called display names that displays a certain string that we told it to display. So that's the functionality of the display name method. So I mean, if I run this program right now, you'll see that I don't get any output, right? It doesn't show me anything, because what the program is going to do is that it's going to read the stuff that's inside the main method. That's the executable lines of code will always exist inside the main method. So if you actually want to print out the stuff here, you have to execute it or call the method in the main method. So the way you do that is, we kind of talked about it. All you have to do is call the method, and the way you call a method is just by saying its name. So within the main method here, we could write just display name. We'll put the parentheses, and then we'll put a semicolon at the end. So just by having the word display name here inside the main method, it should call the method that we just wrote down here. So let's try running that code. And so as we see down here, the output is as intended. It goes hand in hand with the functionality of this method down here called display name. So that's how you call a method from different methods, and we'll look at more examples of that later on as we go on, but just really simply, that's the way you do method calls. And so to move on, now what this slide here is saying is that you're going to want to place methods inside of a class, and you don't want to place methods within other methods. You'll get an error if you do that. You can call methods from other methods, but you can't write new methods within methods. And there's also something called a fully qualified identifier. Now, a fully qualified identifier is just a way of calling a method. So, for example, the JOptionPane class has a method called showInputDialog, and a fully qualified identifier just means that you identify every single aspect of the name here. So right here, JOptionPane is the class, and then the dot separator, and then you have the method, which is called showInputDialog. So you're able to call methods from other classes if you use a fully qualified identifier. So like we did in the previous example, let's just look at an example of calling methods from a different class. So let's say I don't want to change anything, I want to have the exact same method, but let's move this method called display name, let's move that to a different class. So I'll just get rid of it here from this class. I'll just leave the main method here in this class, and I'll create another class here. And this class is has the exact same method that we used in the previous class. So the display name method here now exists in a completely new class called test example, and it doesn't exist in the example class. So if we want to call it, we have to use the fully qualified identifier, meaning we have to have the class name, dot, and then the method name. So in this case, we'll just go ahead and write test example dot display name. And so that's the only modification you have to make in order to call that method from a different class. So if we go ahead and run that, so as we see down here, we see that the output is exactly as intended, and it's the same thing that we got before. Even though the method doesn't exist in this class, you're still able to call it from other classes. So this example is really similar to what we just did. You have a method called name and address that prints out all this information here, and so whenever you actually want to print out, all you have to do is call the name and address method in the main method, and it'll print out all that information. So if you want to look at this, you can. We just went over an example that's really similar to this. Now, we talked about earlier that methods have parentheses at the end of them, and that sometimes there's information that exists within those parentheses, and that's where arguments and parameters come into play. So arguments are just, data items that you use to call a method. So for example here, you have the show input dialog method, and the show input dialog method has two arguments that, it's accepting, and that's null and the string. So anytime you write show input dialog, you open your parentheses, you have to have the word null and then a comma and then whatever string you want to be displayed. Now parameters is, it's kind of the same thing as arguments. They're just from different perspectives. So an argument is from a calling perspective anytime you call a method, and then parameter is from a receiving perspective. So anytime you receive information from a method, it expects certain things. So right here the definition says parameters when the method receives the data item. So arguments and parameters are kind of interchangeable to a certain degree, but just know that they're from two different perspectives. So the example again is the show input dialog method, and that it accepts two parameters, and it's null and string. So anytime you call the show input dialog method, it's going to be expecting to accept those two certain parameters that are null and then whatever the string value is. Now arguments and parameters are kind of used to execute the functionality of a method. So if a method requires additional data, you need to have arguments and parameters in order to fulfill that functionality and execute the method. So this right here is just an example of what it looks like to have parameters in your method. So here you have a method header, and the name of the method is called predictRaise. And now the way you actually declare a parameter in your method is you open the parentheses and you have the parameter type. So whatever the data type is or something, you have the word, in this case, the word double, and then you can call it whatever you want. So it's really similar to like declaring a variable. Like so here we have double and then money amount. Money amount is just a name that they made up. It's just an identifier. So really similar to declaring a variable. So what this code is doing is, you have the value money amount up here that it's going to be passed to the method in the form of a parameter, and then whenever you have money amount being passed to it, you have a variable called new amount here, and then new amount takes money amount and then it multiplies it by the raise. And so whatever information you're getting here from money amount is going to be the same information you're passing to money amount down here, and you're just multiplying it by raise in order to just figure out what the new amount of money is after someone gets a raise. So what this actually looks like is that if you have like a main method, so we'll just go right ahead and write main method here. I'm not going to write it out. And then you have your opening curly brace. So if someone wants to actually pass a value to this predictRaise method, the way you would do it is you would just say predictRaise. And then let's say their salary is like 60,000, so we'll just pass it the value 60,000, and then we'll close the main method. So anytime the main method here passes a value to the predictRaise method, this value of 60,000 becomes the value that goes here, which becomes the value that goes here. So that's just kind of how this functionality works. So let's look at an example of that. So going back to what we have been working on, this exact same example of, we just want something to display its name. So we'll go ahead and do that with parameters. So let's go ahead and write our methods again. So right here we have our display name method, but now we want to pass it information. So let's go ahead and set up a parameter here that says string name. So now anytime we call this method called display name, it's going to be expecting to accept a parameter in the value of a string. So let's go ahead and do that up here. So let's say we can declare the name up here. We'll just say string and we'll call it a name. So a name, and then we'll set that value equal to something. So we'll say here's the value of a name, and then now we want that name to display when we call the display name method. So let's get rid of this down here. So we'll say my name is, and then plus name. So you see how name in the parameter is local to this method, display name. So anytime you call name here, name will display down here. And the way you get the value of name is by having it up here. So whenever you call the display name method, inside of the parentheses, you can just write a name. So whenever you write a name here, it accepts the value of the name that you listed here. So anytime, so this value gets, so the value of Slim Shady gets passed to a name, And then anytime a name is written here, the display name method recognizes that it's a string and it accepts the string through its parameter, and then it displays the name down here. So just know that right here, name and name are just local to the display name method, whereas a name is what's being passed to the display name method. And whenever it's being passed, it's being sent through the parameters as an argument into the display name method, and the display name method takes it and actually allows us to display it. So if we go ahead and run the code here, we'll see that, the output is just as desired. It gives you the display of whatever name you want it to be. So pretty simple. If you kind of confused about arguments and parameters, maybe pause the video and just look at what the code here is doing. It's really not that difficult to understand once you grasp the concept. This is just another example of, a method that's being passed parameters through it. So in this case, you have multiple parameters. You can have as many parameters as you'd like, but if you're having more than one parameter, it's important to know that the parameter order matters and that the data type for parameters matter. So in this case, it's accepting two different parameters, and just know that it's expecting to get the value of money first and then the value of rate second, because that's the order that you listed it as in the parameters. And obviously, the data type matters, because if you wrote int instead of a double, then it would just accept an integer and not a double. And that's critically important because, doubles have like decimal points, whereas integers don't. So that can really mess up and throw off, the calculations of your program. So make sure, that parameter orders are always in place the way they should be, and that data types of the parameters are correct. So now this is just another example of parameters being passed through methods. I'm not going to go over this entire example, but if you want, you can pause the video right here and just kind of look at this class and what exactly it's doing. But really briefly, you have this method called compute commission, and it accepts 3 different kinds of parameters. And so when you actually call the compute commission method up here, it passes the values through into the compute commission method, and then it does all the work in the compute commission method. So take a look at that if you're still not totally understanding parameters and how they work, or if you just want to get a deeper understanding of how they work exactly. Like we talked about earlier, there's certain methods that actually return values to the methods that they're called from, and so that would be called a return type method. So right here it says data is sent from called method back to the calling method. So that would kind of indicate that the method is returning something to you. And so it could return like a primitive data type like an integer or a double, and we'll see that later on. So just know that there are methods in Java that actually return values back to you. And let's say they don't return anything back to you, you would just list the word void there. And if they do return something back to you, and so in place of the word void, you would have the actual data type that's being returned back to you. So if it was returning an integer back to you, instead of having the word void, you would write the word int. And so we'll see examples of that as we go on. And so in this example, we see that we have a method here called predict raise. But now instead of the word void, we have the word double here. And what that indicates is that the method is going to be expecting to have a return data item to it in the form of a double data type. And so as we see, it's being passed, a certain money amount here, and then money amount is going to be listed here as the same thing, whatever, the value is that's being passed to it, and then it calculates a new amount, which is stored right here by multiplying it by the raise. And so after you calculate the new amount, you want it to return that amount back to the method. And so in order to do that, you would have this line of code down here which says return new amount. So anytime you have a return method, it's important to note that there's always going to be a statement at the bottom of the return method that says return and then whatever you want it to return back to the method. So always keep that in mind for return methods. And so, that's kind of what I just talked about. That return statement should be the last line in the method. So you're always going to have a return statement anytime you write a return method. And so what this slide here is saying is that you can chain method calls, meaning that any method can call any number of other methods. So that's important to note because, if you are trying to call other methods and get access to other methods within the method that you're already in, you can call it as many times as you want. You just can't create new methods within existing methods, but you can call them as many times as you would like. So if you remember back to chapter 1 where we kind of talked about classes and instances or objects or attributes of certain classes, there was something called the class, which would be like the student class, and then within the student class you have, maybe you have different students from different colleges at U of H, so like you have a Bauer student or an NSM student. Those would all just be considered objects of the student class. And so this is kind of the chapter that we get into actually creating objects of classes and assigning them certain attributes. So make sure you understand the conceptual stuff before we actually get into the hard coding aspect of it. So as it says here, every object is a member of a class. So you can create objects of classes, and then every object that you create of a class is a member of a certain class. And like it says here, you can create instances of objects and that you can reuse them. And so the class itself, which is kind of like the overarching umbrella over all the objects, is kind of like a template here. So that's just about different class concepts. That's what makes Java an object-oriented programming language. Now, like we already know, you can actually create classes, and the way you create a class is by assigning a name to a class, and then you can determine what data and methods will be a part of that class, and that's totally up to you. And then you just follow the naming convention of naming a class. So you have the word public, you have the word class, and then any legal identifier in order to name that class. So that's something that we already know, right? We've already been creating classes, but something that we don't know is what are called data fields. Now, like I said, in chapter 1 we discussed what classes were, objects were, and what attributes are. So a data field is an attribute. So data field and attributes are just kind of interchangeable. And so data fields are just variables that are declared within classes, but outside of any method. So attributes or data fields kind of perform in a different way from variables. So like we talked about variables and constants, those are all things that are declared within methods and they hold a certain value. In the same way, an attribute holds a certain value, but attributes are declared outside of methods and they're declared inside of classes. So, keep that in mind. Attributes are critically different from variables or constants. Now, one thing to note about data fields or attributes is that they have private access for their fields. So, like we talked about earlier, you have different access specifiers. So you could have a public method or a private method or a public attribute or a private attribute. Now what that means is just that the public method or a public attribute can just be accessed from outside of the class that it's declared in, whereas a private method or a private attribute means that no other class can access the field's value. It's private to the class that it's declared in. And one thing to note is that, it's not private to everything, it's just private to other classes. So methods of the same class are still allowed to use private data fields. Most class methods are public. So you'll see in examples maybe later on where there are some methods that are actually private, but attributes or data fields for the most part will always be private. So what that means is just that they cannot be accessed outside of the class that they're declared in, and you can use them in different methods in the same class in which they're declared in. So that's just an overview of what an attribute is. So one thing that we haven't really talked about yet is static and non-static. And so, like in the main method, we have public, static, void. So we've talked about what public means, we talked about what void means, but we haven't really touched on what static means exactly. So, you have things that are static versus things that are non-static. And so what static means is that a method or an attribute is going to stay the same amongst all instances of that class. So every time you see the word static, just know that static means that every method or every attribute that is static just means that it's shared amongst all instances of that class. So anytime you create a new object, if a static attribute exists, then that static attribute will exist in every single object of that class. whereas a non-static attribute will not exist in every single attribute of that class. So you have what are called non-static methods. So like I said, if a static method is something that's shared amongst all instances of a class, then a non-static method is not shared amongst all instances, meaning it's specific to a certain object or a certain instance. So those are called instance method because they belong to objects. So if a non-static method exists, it only exists within that object or within that instance. And then in that same kind of line of thinking, you have non-static data fields or non-static attributes. And what that means is that each instance of the object will have its own copy of the data field. In the example here, it's that PeopleSoft ID is like an attribute that all UH students have. But that attribute is not static, because if it was static, then we'd all just have the exact same PeopleSoft ID. So the ID number is non-static because it's an attribute that exists for all of us, but the value of that attribute is completely different for every single instance or every single object of the UH student class. So that's just kind of the breakdown of what static and non-static means. Static and non-static are kind of it's very important to understand because later on when you're actually creating these methods and you're creating these attributes, you're going to want to know if they're being declared amongst all instances of the class or if they're only specific to a certain object, especially when you're taking the quiz. So static versus non-static is something that you should definitely know. And so, we kind of touched on what non-static means, so let's talk about what static means. So a static class variable are not instance variables, and they're shared copies amongst all objects of the class. So if you did have like a static attribute, it'd be something that every single object of the class shares the exact same value. And so this is just kind of a breakdown of, what it means to be an instance variable or a static variable. So it says an instance variable is one per object, and that every object has its own copy of an instance variable. So an instance variable is just something that is declared within a certain object or within a certain instance, like in the example here. And so that means that every single other object will have a completely different value. That's kind of what we talked about up here, that static class variables are not instance variables, in that static class variables are shared amongst all objects of that class. And so like it says down here, a static variable is one per class, and that every object of the class shares the same static attribute. So like we have public static, int x equals 5, it means that every time you create an object of the test class here, the value of the variable x or the attribute x will never change. It'll always hold the exact same value amongst all objects of the class. So hopefully that provides some kind of a breakdown of what it means to be static versus non-static. So now we're going to talk about what are called get and set methods. So like we mentioned earlier, we said that attributes or data fields are always going to be private. So in this example here, we have an attribute called empnum for employee number, and we see that the attribute called empnum is actually going to be a private integer attribute. And now what that means is that because it's private, it's not going to be able to be accessed from any class outside of the class that it's declared in. So, the employee class here is the only class that can access empnum. Anytime you try to access empnum from outside the employee class, you're not going to be able to because it's a private attribute. And so, maybe an instance comes up where you want to change the empnum or you want to set a new empnum. The way you do that within another class is by using what are called get and set methods. So in this example, you're going to have to create public methods in order to grant you access to private attributes. So anytime you have a private attribute that you're trying to access from another class, you have to use public methods called get and set methods in order to, come into this class, get the value, and then take it back to the other class in a public way, because you have to use a public method in order to access the private attribute. So firstly, let's just look at this get method here. So what the get method is doing is it's just getting the value of whatever empnum is. So like here, right here, it says, and the method has to be public because you want to access it from other class. So right here it says public, and then it has a return type of int because you want to return to you the value of empnum, and then whatever you name the method. In this case, we'll call it get empnum. And then all this method is doing is that it's just returning the value of empnum to you. So all you're going to write here is just return empnum. And so now this method here called getEmpnum is just going to hold the value for whatever empnum is. So if you ever want to access empnum outside of the class, you're going to have to use the getEmpnum method in order to access the private attribute of empnum. And so let's say you want to change employee numbers. And so the way you do that is through what is called a set method. So in this set method here, it's the same thing. The method has to be public. So you have a public method, and then there's no return type in set, so just the word void. And then you can call it whatever you want. In this case, we'll call it setEmpnum. But setEmpnum is being passed a parameter. In this case, it's an integer called emp. And now from there, you have this integer emp, and so you're going to assign emp any kind of value outside of the class. So let's say their employee number is 123, and you want to change it to 124. So you just pass it the value 124 through setEmpnum, and so you have the value emp, which is the same thing as the value emp here, and then you set emp or emp to employee number. So whenever 124 gets passed to setEmpnum, the method, then it gets reassigned to empnum, which is the private attribute that exists inside the employee class. So just because you have a private attribute doesn't mean that it can't be accessed. The way you're able to access private attributes is by declaring public methods and then just having the methods have a certain functionality that allow you to, maybe modify a private attribute or just get the value of a private attribute and bring it to another class. Now, like we talked about earlier, you can actually declare objects of certain classes, and there's a certain way to do this. There's a certain naming convention and syntax that you have to follow. So you can declare an object of any class that exists in your program. So in this case, let's just use the example of the employee class. So let's say there's a class called employee, which is the one that we just worked with, and we want to create an object and just call it an employee or some employee. Now the syntax of the way you do that is, the first thing you have to have right here is the name of the class. So the class is employee, so we have the word employee, and then, so that's the name of the class here, so we'll just write class. And so the second thing here is just the identifier of whatever you want to name the object. In this case, we'll call it an employee. And then you have the word new here. You always have to have the word new, and then just the name of the class again. So in this case, it's employee, and you have to put parentheses and the semicolon at the end. So that's the way you declare an object. So if you ever want to declare an object or create a new instance of a class, this is the syntax you have to follow. It's the class name followed by the name of the object or the identifier, whatever you want to call the object, and then an equal sign, and then the word new, and the name of the class again, followed by parentheses. So that's the way you declare an object of a class. So let's look at an example here of what it actually means to declare an object of a class. So in the example that we've been working with already, we have a method called displayName in this class called example. But let's say we want to access this method from a different class. So let's just get rid of the displayName method here, and we'll move it to this class called testExample, and then we'll go back to the example class, and then let's create an object of the testExample class. So we'll say testExample, and then we'll just call the name of the object, we'll call it an object, and then the word new, and then testExample, and then you have your parentheses, and then your semicolon. So now we've declared an object of the testExample class, which only just holds this displayName method. And so we declared an object of this class, and we did that in the main method in a completely different class. But now, you can do certain things with objects. So let's say we want to actually display the name through the method called displayName. So all we have to do is the same kind of fully identified qualifier here. We'll just say an object dot display name. So what that will do is that it'll go to the test example class, and in the test example class we declared an object called onObject, and then you're able to access the methods from that class. So from the test example class, where the display name method actually exists, you're able to access this method because we declared an object of this class, and now that object of the class has actually access to this display name method. So if we go ahead and run the code, you'll see that it works just fine. So that's kind of an example of creating an object of a class and then having that object call methods from its class. So let's just look at some more examples of what it means to actually declare an object of a class. So in this example here, we're just going to be using the same example of an employee class like we saw above. So we have a class called employee, and then we want to create an instance of the employee class, and we'll just call it clerk because we have an employee that's a clerk. The syntax is the same, it's just new employee. And then maybe we have another one called driver. And now every single object of the employee class obviously has an employee number. And let's say, we're just putting these guys into the system and we want to set an employee number for the clerk and we want to set an employee number for the driver. Now the way you do that and the way you access that private attribute that exists in the employee class is kind of like how we talked about earlier, is using get and set methods. So in this case you have clerk.setEmpNum to 345. So maybe his employee number is 345, and then we can use the setEmpNum method, which is a public method, in order to set the private attribute of empnum for the clerk. You can do the same thing here for the driver. And then maybe when we want to display their employee number. And so in the same way you can set their employee number, you can also display their employee number by just using the getEmpNum method, which was another public method that we had in the employee class. So let's say you want to display the number of the clerk, you could just do clerk.getEmpNum, and that would display whatever the clerk's employee number is. And obviously, these guys have different employee numbers, and so let's say you want to display the employee number for a driver, you would just do driver.getEmpNum. So that's just a really brief overview of what it's like to use get and set methods in a practical scenario. And so, you're creating these objects of the employee class, you're setting certain employee numbers, and you're displaying the employee numbers using the public methods that are get and set. And so that's just kind of the idea of data hiding or encapsulation that we talked about in chapter 1. So since data fields are usually private, in order to access them, you have to use set methods and get methods. And so that's just saying that anytime something is private, you can still access it using get and set methods. And now one thing to note is that whenever you're organizing classes and you're actually writing these attributes, you always have to place data fields at the beginning of a class. You can never put attributes or data fields inside of a method. It's always going to go before the methods. They're going to exist outside of methods, but they're always going to exist within classes. But a method can be placed in any order. Your main method could be the last method in your program, and your display name method could be coming before your main method. It doesn't matter what order your methods are in, they will execute regardless. So that's just two little things to keep in mind whenever you're organizing your classes. And so now the last thing we're going to talk about here is what are called constructor methods. Just know that we're going to go more in depth into constructor methods in chapter 4, so this is just a really general overview of what a constructor method is. So a constructor method is a specific type of method that's created every time you initialize an object of a class. So anytime you have that syntax where you do like employee, clerk is equal to new employee, anytime you create a new object, Java by default creates a constructor method anytime you create an object of a certain class. Now you can manipulate this and you can create your own constructor method, which is what it says here. And then the name of the constructor method is always going to be the same as the class name. So right here it says it's going to be the same as the class. So if you're using the class called employee, your constructor method is going to be employee, and then you have your parentheses because that's obviously a method. So that's just a really general understanding of what a constructor method is. Just keep in mind that every time you create an object of a class, Java by default is going to create a constructor method for you, and the way you can manipulate certain objects is by using the constructor method, and that the constructor method will always be the same method name as the class name. So let's just look at what that means exactly. This is just an example of what a constructor method looks like. You have the word public here, and then the name of the method, which is always going to be the name of the class. So if we're declaring something in the employee class, the name of the constructor method is always going to be employee. So, it's going to have the same name as the class it constructs. It cannot have a return type, and it's always going to be a public access modifier. So that's just certain things to keep in mind about constructor methods. We'll go more in depth into what constructor methods are and what they do in Chapter 4, but this is just an introduction into what they are exactly. So that kind of covers it for the conceptual stuff on Chapter 3. Hopefully it wasn't too confusing. I didn't go too fast. If you guys, want to learn more and go more in depth into certain things, maybe you don't quite understand what static is versus non-static, I would definitely refer you to the textbook. The textbook has really in-depth knowledge, in terms of, certain concepts that are discussed. So definitely refer to the textbook if you don't understand anything that I talked about, because it's important to understand this stuff, because later on, as the class goes on, this stuff is going to build on itself, and, if you fall behind now, it's going to be extremely difficult to catch up. So that's all the conceptual stuff. So right now we're just going to jump into some coding examples and kind of dissecting certain code and kind of just looking at what it means to just create new methods and just access these methods with different parameters and stuff like that. And so let's jump into an example real quick. So in this example, we're not actually going to be hard coding anything. We're not going to be writing out the code, but rather we're just going to be dissecting what this code is actually doing and how it's functioning. So the purpose of this program is to take a certain number of eggs and then calculate how many dozens of eggs are in that total number of eggs, and then just tell me how many left over there are. And so let's jump into what exactly it's doing, and let's just take a closer look at this program. Now, before we actually get into dissecting this code, one thing I will say is that you guys should definitely pause this video and maybe try to look over the code just to see, what it's doing exactly, maybe test your own knowledge. It's always beneficial to do that, kind of get an understanding of where you are and what you understand. So definitely real quick, take a look at the code, and, hopefully you guys can see what it's doing. If not, we're about to go over what it's doing exactly. And so here we have a class called eggs. And now what the program is doing, like I mentioned, it's just calculating how many dozens of eggs are in the total number of eggs, and just telling me how many leftover eggs there are. And so let's get right into, seeing what each method is doing. So let's first start with our method here called calcEggs. And so we've created a method and we've called it calcEggs. And what that does is actually doing the mathematical work behind calculating how many eggs are there total, and then telling me, how many dozens there are, and then how many leftover there are. So first in this line of code here, you're declaring, your variables dozen and leftover, and then in these two lines here, you're just doing the math behind, how many dozens of eggs there are by just dividing it by 12, and then how many leftover there are by doing modulus 12. Now, the important thing to note here is that there's never a total number of eggs that are declared in the calcEggs method. So if you look at this method here, you're never actually being told how many eggs there are total. You just have this variable here called total eggs, and then you have, variables here called total eggs, and then the same thing here for leftover. So you just have this variable here, but it's never actually initialized or declared. So, how can you do mathematical operations with it if you never give it a value? And so that's where the parameter comes into play. So, obviously in this calcEggs method, it's accepting a certain integer called total eggs. And now you get total eggs from whatever value is being passed to calcEggs. So if you see here, whenever you call calcEggs method in the main method, whatever number of eggs holds here is being passed to total eggs here. So anytime you reference the method name calcEggs and then you pass it a certain value, it's going to be sent to the actual method, and then the method from the method header, it's going to send total eggs to the values here. So now you can use total eggs in your calculation. So that's kind of the chain that's being done with, the parameters here. So anytime you want to pass a number to it, all you have to do is just call the method and then pass it a number, and that number is being passed to the calc eggs method so that you can use that number in your total egg calculation. And so now you're asking, where does the number come from in number of eggs? So as you see in the main method here, number of eggs is declared right here. So in this example, we have number of eggs as 153. So anytime you see number of eggs here, just know that it says 153. So number of eggs is first declared at 153, and then they pass number of eggs to the calc eggs method, and the calc eggs method sends the number to total eggs because it's just the name of the method that accepts a parameter, so there's an argument to it. And so anytime it does that, from there it takes total eggs and it allows you to use it in the calculations here. So this is just a demonstration of just seeing, the breakdown of how to get from one method to another method and how to manipulate certain data. The rest of the code, is pretty simple. You're just displaying the total number of eggs and then the dozens, the leftovers. I'm not too concerned with the mathematical operations behind the code here. I just want you guys to understand, how these methods are functioning next to each other. So you have the main method that's just initializing a value for a number of eggs, and then in the main method you're calling the calc eggs method and you're passing it a certain value. Then the value that you're passing it is being sent to the calc eggs method, and then from there calc eggs, you can use it to calculate the total number of eggs, and then you can use the total number of eggs to do your calculations in the calc eggs method. So, hopefully that example kind of gives you an understanding of what it means to pass certain information or certain data through parameters in different methods. I hope that makes it clear. If not, maybe go back to the examples that we discussed earlier and just kind of brush up on what it means to pass certain things to parameters. So hopefully you guys understand this fully. If not, hit me up with any questions you may have. And that's going to do it for this video. We went over the concept stuff, we went over some coding stuff. So hopefully we touched all bases. So that's going to do it for this video, and I'll see you guys in the next one. Bye.